Algebra 2, Section 2.1. What I have here at the first is something organized in a certain way because I want you to start associating this column together and this column together. So we're going to define what a function is later in this lesson. And when we have a function, what we'll have is an input and an output. You're probably most used to using the variables x and y, although that doesn't have to be the case. It's a good place to start since Algebra 1, they use a lot of x and y. IV and DV stand for independent variable and dependent variable, and then there's domain and range. Okay, so you need to understand that all of these go together. The variable that we typically use, x, is typically an input. It's typically the independent variable, and then domain stands for all possible x's or all possible inputs, whereas y is usually the output, right? And again, it's not always y, but a good place to start. Y is usually the output, and it's the dependent variable. So what is that about? So the dependent variable depends on the independent variable. A lot of times it's just kind of the way the equation is organized. If it's in the form of y equals and then everything else in terms of x, it makes a lot of sense that you can plug things in for x, do the arithmetic there, and get an output for y. But also it can depend on the situation. Okay, if you're running a race, the amount of time that elapses would be the independent variable, and how far you can go would be dependent upon that, right? It's assuming you know what your typical speed is. Okay, and then there's range, which is all possible outputs. Okay, now I'm going to get this out of the way right away. There's only one domain in any given situation, and there's only one range in any given situation. Okay, it's a singular thing. It can have many components in it, but it's one thing. It's like saying the sophomore class. There's only one sophomore class. There might be 300 people in it, but there's one class. The domain is like that. It's all possible x's as a collection of one thing. So don't ever give us an explanation that says, you know, the domain's this or the range is that, because there's not plural domains and ranges in any one situation. Okay, so then a definition: a relation is a set of pairs of input and output values. That's a simple definition. Now, with that then, I give you this. It says to graph the relation, they give you 5 ordered pairs. Now I'm going to assume everybody can graph ordered pairs. You're in Algebra 2 after all. But just a reminder that you do the x first and then the y. So negative 3, 3 is 3 to the left and then 3 up. 2, 2 is right 2, up 2. And they've graphed all 5 of these. And with that skill, then, we should be able to do the reverse of that, which would be they give us the points, and you can list the ordered pairs. So just to pick one, if I picked this one right here, that's 3, 2. This one down here would be positive 2, negative 3. We can list the ordered pairs. And then they say find the domain and range. Okay, so they list the ordered pairs like this, and that's what you should do as well. Just to separate them with a comma. I don't know that you necessarily even need the braces out here, but that's what they did. The braces would be more important for listing domain and range. Now again, domain is all possible inputs or all possible x's in this case, and that would be all of the red numbers. By the way, you do not need to repeat them. If there's a repeat, you do not need to repeat them when you list them in the domain. So the domain would simply be negative 4, negative 3, negative 2, 2, and 3. And again, you want to use braces like this. This kind of the kind of notation that we use for domain and range. I'm going to get a little bit more into that here in just a moment. Okay, the range, notice that there's a 4 here and a 4 here. So you don't need to repeat those. I do like it if you would put them in numeric order. So the smallest one would be negative 4, then negative 2, then 2, and then 4 again appears twice. You only need to list it once. The range is negative 4, negative 2, 2, 4. Okay, domain and range. Now, with that, take a look at these 2 graphs here. I'm going to kind of introduce something to you, and I'm sorry if this video gets a little bit long. Use the pause button as you need to, because we're introducing a new topic now. What I'm about to introduce to you here we'll do more extensively on a worksheet in a few videos from now, but I want you to just see this right now for the start, because we're talking about domain and range. Again, domain is all possible inputs. This is known as a parabola. We'll get really into these in chapter 5. What values can x be here? Or maybe I should ask it this way: is there anything that x can't be? Is there anything that any number that this parabola won't eventually reach or jump over or whatever for the domain? And the answer to that is no. You may think that this is getting really steep, these are getting really steep, but in actuality, if we could get up high enough, I can get you left far enough, right? We got infinity to work with after all, and the same thing with the right. So really, this is all real numbers. And in the past, you might have even said that in words. We now want to teach you two different methods for listing domain and range. And I'm sorry that it's two, I really am. The first way that I'm going to teach you is the way the book does it, and this would be kind of your default position. But also there's a different way that pre-calc does it, and they asked us to introduce this to you here. And again, I'm going to get more into that in a video down the road, but I'm introducing it now. So the first way is by using inequalities, although there's no really inequality here because we're talking about all real numbers. So all you do is identify the variable, and then you would use an inequality to say any restrictions on the variable. This one has none because it's all x's, so we just do that. Now, the way that looks in what's known as interval notation, I might just call this standard notation, and then the way that would look in interval notation actually looks like this. That's a parenthesis. I'm right up at the edge of my starboard here, so I'm in a little trouble. Negative infinity to infinity. You familiar with this symbol, infinity? That's what x can be. It can go all the way to negative infinity, all the way to positive infinity on this graph of this parabola. Okay, that's called interval notation. Now let's do the same thing for range. Is there anything on this graph that y never gets to? And the answer is yes. It never gets below -2. So standard notation, you're going to identify the variable. We always put a line here to kind of separate it off. And then we're going to say y is greater than or equal to -2. You see, because the y values on this graph, they're going to go up forever in two places, actually, in two directions, if you will. And they'll never be below -2. They start at -2 and go up from there. Okay, so the variable is y, and the range is -2 and above, so to speak. Now, how that looks in interval notation is a bracket. The bracket says to include this point. Right, we're stopping here and we're including this point. If it were not that point, like greater than or less than, but not or equal to, then we would use a parenthesis. And since you can't really count to infinity, they use parentheses with infinity. So anyway, this is a bracket, and it's -2 to infinity, and you just separate them with a comma. Okay. Now, if you would like, you could pause the video right now and see if you could think up what the domain and range of the next one would be. If you didn't pause it, I'm going to move right into it, though. The domain goes from -2 to 2. At least that's what I was intending to do when I drew this. So identify the variable, and then -2 less than or equal to x less than or equal to 2. Coming out of what we did in chapter 1, this kind of notation should make sense to you, right? It goes from here at -2 all the way to here at 2, and never gets beyond that, never gets beyond -2 this way. So that's a good way to represent the domain. Okay, let's just do the range here too. Y, where it's -3 less than or equal to y less than or equal to 3. Right? From -3 to 3. In interval notation, again, what that means is, what the bracket means is include this number. It goes from -2 to 2. In a lot of ways, the interval notation is shorter. Many times it's shorter. And range would be -3 to 3, inclusive of the numbers. So use the bracket. Okay? Now, something called a mapping diagram. I'm going to just demonstrate for you what it is, but the word here being given is mapping diagram. Okay? And a mapping diagram basically does this. You list the domain here and the range here, and you use arrows to point one to the other, right? So we have -1, 1, 1, and -1. Looks like we only have two numbers in the domain, -1 and 1. We have 7, 3, 7, and 3. Looks like we only have two numbers in the range as well, okay? And then you're going to look at the ordered pair, and you're going to see that -1 as an input gives you 7 as an output. So we're just going to do this. That make sense? 1 maps to 3. That's like this. 1 maps to 7. That's like this. And -1 maps to 3, that's like this. So strangely, in this example, everything in the domain maps to everything in the range, okay? Now here's a completed mapping diagram. Oh, you know what? I don't want to do that yet because it's asking about a function. So let me go back here and define a function. A function is a relation in which each input value is paired with exactly one output value. Sometimes when I'm in class and I have more time to teach this, I draw the function machine. You drop something in the function machine. Is there a clear output? Is there any confusion as to what the output would be? We'll see an example of that in just a second. But basically, when there's an input, you have exactly one output, or that is paired to it. Okay, so that's what a function is. Notice that it used the word relation. We define relation up here. A relation is a set of pairs of input and output values. A function is a particular kind of relation. Okay. So again, here's a mapping diagram. What this is saying is -3 maps to 4, -3 maps to 5, and 2 maps to 5. Okay. Now, here's the question: If does each input have exactly one output? Well, 2 has exactly one output. 2 has 5. So this isn't a problem. You see 2 arrows coming in at 5. That's not a problem. Here's the problem. Here's why it's not a function. I shouldn't say it's a problem. It's why it's not a function. You plug -3 into this relation, you don't know if you're going to get a 4 or a 5, right? It maps to 2 different things. So is this thing a function? No, not a function. Okay? And then that leads us to something known as the vertical line test. Okay, now let's just kind of put everything together. We had a list of ordered pairs. If I asked you if something was a function and it was a list of ordered pairs, what you would be looking for would be a repeated number in the x. I don't know if that came through with the examples that we just did, but that's what you would be looking for. It's a little bit more of a visual to see it in a mapping diagram. And if you see an arrow leaving from I should say more than one arrow leaving from the same element of the domain, the same input, that's the equivalent of what I just explained in the list. That would not be a function. And the lack of that would mean that it is a function. And then if we graph them, this then results in something known as the vertical line test. If there are 2 numbers, or excuse me, 2 points that are top over bottom from each other, then this is what we would say it fails the vertical line test. You can draw a line through 2 points. This is a problem. In fact, let me even scroll back to the earlier example to talk about that. You see here, there is no vertical line that I can draw that would pass through more than 1 point, right? No vertical line. And we're not just talking about the y-axis, we're talking about any vertical line. If I draw a vertical line through any of these points, it doesn't pass through the other one. So this is a function. This set of points is a function because it passes the vertical line test. By the way, we like the explanation better that you would say for each input there's exactly one output. But we'll also use the lingo sometimes of passing or failing the vertical line test. If it passes, it's a function. If it fails, it's not a function. So what about this then? Use the vertical line test to determine whether the graph represents a function. You see the problems that we do where they just list the ordered pairs, that's a good place to start, but that's not where we're going to stay. We're going to look at continuous functions and things like that, ellipse that I just showed you, etc. So the question is, can you come up with a vertical line that would pass through this more than once? And the answer to that is no. No, there is no vertical line that would pass through this more than once. So this is what we would say passes the vertical line test. For each input, there's exactly one output. Yes, it is a function. Yes, or yes, it's a function, or whatever. Okay, and lastly, something called function notation. This f of x, you've probably seen this before, and it confused you. I see a lot of confusion that comes into Algebra 2 about this. Please be not confused. It's not multiplication. This is not f times x. All this means is y. It's just the dependent variable. It's the output. It's pronounced f of x. F of x, all it means is y. Now, as soon as I say that, I usually get a question, why don't you just say y then? Why do we have to have another thing? Well, it's illustrated very well why function notation is a benefit to us when they ask for f of 2, right? So x is the dependent variable. X is the independent variable. You could plug in here you can plug the 2 in here. And while f of x is the dependent variable, we can see the number in this notation, and we can write it like this. F of 2 is equal to negative 2 squared plus 1. Okay? Just to jump down to the next one, f of 2 here would be the absolute value of 3 times 2. Let's go ahead and solve this one. Remember that that negative, which is not in parentheses, just means the opposite of 2 squared. So that would be negative 4 plus 1, or negative 3. Here, 3 times 2 is 6. The absolute value is 6. Here, f of 2 would be 9 over 1 minus 2. 1 minus 2 is negative 1. 9 over negative 1 is negative 9. Okay, and that's all we have for you. Thanks for watching.